This is video 532. In this video, we're going to continue looking at double angle and half angle formulas and how to verify identities with them. So taking a look at the first example here, we're trying to verify this identity. So I see cotangent of x over 2 equals sine of x minus 1 over 1 minus cosine of x. So I see the x over 2 and I know that's going to be a problem because my result has just x in it. So while the left side doesn't look very complicated, I'm going to simplify that by first of all changing it to 1 over tangent of x over 2 and then using my half angle formula. So my half angle formula says that the tangent of an angle over 2 will equal 1 minus the cosine of the angle over the sine of the angle. And there's multiple formulas to use for tangent, but you'll see in a moment why I chose this one. So I'm going to replace the denominator with this fraction, 1 minus cosine of theta all over sine of theta. Now to simplify this quickly and efficiently, I'm going to change this division to 1 times the reciprocal. So I'm going to flip the denominator to be sine of theta over 1 minus cosine of theta. And that is my result. Notice I met my goal. I'm at the end goal. Okay, so this next example, example 5, we're going to look at one that's in the book. It's question 75. So we've been dealing with some of these angles, these equations that have been graphed for us, and we have to finish the identity as the instructions stay here. It says finish the identity, use the graph to make a conjecture. And my conjecture is that this graph, if I sketch this in, I can see a sine wave. It looks like the period only goes to pi based on my range, my domain here. So if that sine wave has a rule of sine of 2x, it also has an amplitude change of 2. So the original function that was graphed in black would be 2 cosecant of 2x. So my conjecture is that this left side of the equation listed here is equal to 2 cosecant of 2x. And I'm going to prove that by using some double angle formulas. So let me take a moment to rewrite that down below here. That the original formula was cosecant squared of x over cotangent of x is equal to 2 cosecant of 2x. Okay, so we know that we don't have any definitions, double angle formulas for cosecant and cotangent, but I'm going to work with changing these to sines and cosines over the course of time here. But one thing I do notice is that this has a cosecant squared. In your Pythagorean identities, there is a Pythagorean identity that relates cosecant and cotangent. So be prepared to recognize those. The identity is 1 equals cotangent squared of x plus, 1 plus cotangent squared of x equals cosecant squared of x. So that's a Pythagorean identity that I can use right away to perhaps help me simplify the left-hand side. The right-hand side, I do need to get rid of that too. So we're going to do that as well. So we're going to work with both sides. We're going to do what's called meeting in the middle. So I'm going to start with taking this cosecant squared of x and replacing it with 1 plus cotangent squared of x. I like this because I see the denominator here is going to get some simplifying that's going to be allowed to happen. I can simplify this left side further as 1 over cotangent of x plus cotangent squared of x over cotangent of x. I simply separated the numerator with the denominator being the same on left and right. Now I see that 1 over cotangent equals tangent of x. And when I simplify this, I can cancel a cotangent from top and bottom. I get cotangent of x, which is just tangent of x plus 1 over tangent of x. Actually, you know what? I may not want to do that because I'm thinking I'm going to want sines and cosines. And I know how sine and cosine are related to tangent and cotangent. Tangent is sine of x over cosine of x. And cotangent is the reciprocal, cosine of x over sine of x. Okay, so I've gotten the left side rather simple, and I've got sines and cosines. I didn't have to deal with any fractions and fractions. If I would have taken the original product, the original fraction here that you see, I would have had to have fractions on top and on bottom, and that just would have gotten messy. So by doing it this direction, I slightly get a little bit more easy answer. Now this I'm going to have to simplify by using my double angle formula for, I'm going to take this and make its reciprocal 2 over sine of 2x. So I need to replace the sine of 2x with what it's equal to using my double angle formula. So my double angle formula listed above here is quite simple, 2 sine of theta cosine of theta. Okay, so I'm going to take this and it's going to turn into 2 over 2 sine of x cosine of x. And I see the 2's on top and bottom will cancel to make 1 over sine of x cosine of x. Okay, so this is rather simple in terms of sines and cosines. And remember my other answer over here also had sines and cosines. So I got to figure out how to make this more complicated one look like the one that I have here. So now I can see where I'm headed. It looks like I'm going to need common denominators, so I'm going to times the top and bottom by something to get the same denominator. The second fraction needs cosine in the denominator. The first one needs sine. I also like this because I see my denominator appearing the same as the denominator over here. So I'm going to get sine squared of x over sine of x cosine of x and plus cosine squared of x over sine of x cosine of x. I'm seeing the Pythagorean identity pop out. I'm seeing that when I put these two fractions together over one denominator, I'm going to have 1 over sine of x cosine of x. That's also where I left the right-hand side. So I have met in the middle, noting that I now have equal expressions on left and right, and therefore these two expressions at the beginning were equal. So I verified the identity. So leaving things in tangents and cotangents and cosecants may be helpful. It may keep your life a little bit simpler. So let's take a look at another verifying identity. So here's example 6, the final example for the section. So I have this large 4t, and over here I just have t. So once again, while the left-hand side looks really simple, we don't want 4t in there. We need to break that down, and we're going to break that down by thinking of this first as the cosine of 2 times 2t. Okay, so 2t is our theta, and we're going to use the cosine of 2 theta, the double angle formula, to break this apart. Okay, the cosine of 2 theta can be written as in 3 different ways. So remember that from the previous problem, I'm going to flip it back for you, that it can be written in 3 different ways. Now I like this way the best because it deals just with cosines and no sines, and that is ideal for me because of what I'm hoping to accomplish. I don't have any sines here. So I'm going to use that identity to replace this cosine of 2 theta. Okay, but know that my theta is 2t, so we're breaking it down only in half. So we're going to break it down and we're going to get this to be rewritten as 2 cosine squared of 2t minus 1. So I've broken it down from 4t's to 2t's by using one of the identities. Now the trick is I need to break this down further because I don't want even 2t's. So I need to take this expression, I need to first note that it's squared, and then I also need to leave the 2 and the minus 1 alone. So the 2 is going to wait. I'm going to get a replacement for the cosine of 2t, and I'm going to square it because of the fact that it was squared here, and the minus 1 is going to stay. So the only thing coming out is the cosine 2t, and once again I'm going to use the formula 2 cosine squared of t minus 1. But that's an identity relating a double angle and the equivalent half of the angle. So I'm going to replace this with 2 cosine squared of t minus 1. So that's the quantity that I'm going to square. So let's see, I'm going to work this out by using my FOIL or my special products. I'm going to square this quantity that you see on the inside, and I will get 4 cosine to the 4th t minus 4 cosine squared t minus 1. I'm sorry, plus 1. And then I still have this minus 1 on the other side. So I'm slowly getting close to where I want to be. If you're not sure how to convert this to this, make sure that you utilize FOIL, a special product, or a generic rectangle. Bring your question into class if that still doesn't help you. So now I'm going to distribute the 2 across the board here and get 8 cosine to the 4th t minus 8 cosine squared t plus 2. And then once again I have my minus 1. I'm almost at my goal. I simply simplify the plus 2 and the minus 1 and make it plus 1, and I accomplish my goal of cosine to the 8 cosine to the 4th t minus 8 cosine squared t plus 1. And I met my goal of verifying the identity. So this one looked kind of weird at first, but you have to work with that double angle twice and be really careful and cautious with that squaring on the first cosine of 2t that we saw early on up here, and then make sure you don't lose your minus 1 and your 2 in the beginning. So it kind of worked with a lot of algebra tricks there. So I have a couple more checkpoints I'd like you to try. Remember, verifying identities are much harder for many of us. So try these next 3 checkpoints and bring your questions into class, but make sure you give them all a shot on your own. Try to use what you know about these different angles and the 3 examples that we talked about here.